Hello, my name is Josh McCoy from Shoshone Junior High School in Shoshone, Wyoming. I'm a database administrator and 7th and 8th grade STEM teacher. On the Active Authentication team with me is Camille Connor from Orlando, Florida. She's a career tech educator at Dr. Phillips High School, and Ethan Highsmith, also from Shoshone, Wyoming. He's a help desk technician and teaches high school STEM. Our team conducted a multimodal authentication research project for WySTACK this year. We used Python alongside Jupyter notebooks to edit and create the code needed to extract and process varying types of data, namely image and numerical time series data. All the data we worked with came from 5 test users. Diagnostic data from the device's gyroscope, accelerometer, camera, and keyboard were all collected. For the image data, we first had to extract still photos from the videos of the test users. To do this, we ran a Python script that would scan the videos using a library called OpenCV and set it to grab images frame by frame. After this, we then used another script to run facial recognition on each set of images for each user. The purpose being that we wanted only face data in the image and as little background information as possible. In order to do this, we used a deep neural network, once again provided by OpenCV, and sent all the images through it. After a little bit of trial and error, we got all the image data we needed to train our facial recognition model. We then passed the images through a convolutional neural network. That trained models on the images we provided for each user. Next, we trained our own facial recognition model based on the processed data. Going from top down, we started a sequential CNN. When we started with our first layer that took the extracted images we made earlier, it turned them into RGB data that can be passed along the neural network. The next layer uses average pooling and takes sections of that RGB data in a grid-like pattern, just like the original image, and then puts them together as the average values of all the RGB data present in that section of the image. After these first 2 layers, the process repeats itself using the new values, and then a dropout of various nodes occurs. The dropouts help to combat overfitting, which is a common behavior in models that are overtrained and suffer in performance when faced with outside data, or in the case of our images, data that it was not trained on. After this, it repeats again, and we flatten the data, which takes on the grid or 2-dimensional information that we have and makes it 1-dimensional. The model is then compiled from this data, and we move on into testing and validation. We fine-tuned the hyperparameter to improve performance through node activation functions and dropouts. Most of the user models performed very well from the start, but we did have troubles with 1 or 2 users. After tinkering with some parameters in the model generation, we were able to get models that all scored over 97% accuracy with a false acceptance rate of 4% and a false rejection rate of 0%. Our time series data was a little more straightforward to work with. We chose to opt out of using our accelerometer data since in testing it showed to be erratic and inaccurate. Moving forward with our gyroscope data, we first had to do feature extraction to prepare the data to enter our 1-dimensional CNN, and then create a model using nearly identical methodology to our face model. The results from the gyroscope model were nothing spectacular. There is a reason it's not used on its own to allow or deny access to mobile devices. It proved too inconsistent to train reliable identifiable behavior in small hand movements. But with the models from our gyroscope data made, the very last step was fusing the 2 modalities together. We needed to take both models, give them faces and gyroscope data at the same time, and then combine their outputs to give the end result of either a genuine or an imposter user. The end results were actually quite promising. Out of all 5 users tested against a second series of data, 3 of them had an accuracy rate of 100%. 1 had an accuracy rate of 80% with a false acceptance rate of 25% and a false rejection rate of 9%. The last user had very poor accuracy of 40% with a false acceptance rate and a false rejection rate of 100%. Our team believes this was due to an issue with the user's face model, since the diagnostic data reported the model with a high confidence response every time a picture was handed to it. Through the implementation or feature extraction, machine learning algorithms and deep neural networks, as well as convolutional neural networks, we were successful in transforming this data we were given into identifiable features for user authentication. The pivotal finding of our research was the significant improvement in authentication accuracy achieved through fusion of both image and gyroscopic modalities. While the individual modalities, especially facial recognition, demonstrated commendable accuracy, the combination of the gyroscope and facial videos exhibited even greater effectiveness. The notable enhancement in accuracy highlights the potential of multimodal biometric authentication as a robust security measure for mobile devices. Plans for implementation in the classroom have come together pretty well. Camille, Ethan, and I all have lesson plans in place to begin teaching a unit on Python coding. Usage of Jupyter notebooks was something that was new to all of us. They presented a very clean interface for students to easily write, comment on, and organize code. All three of us have plans to introduce foundational concepts of Python coding to our students with a PowerPoint presentation, and we'll follow this up with a check for understanding so that students can retain the information better. And then we all have plans for a second hands-on coding activity that we'll be utilizing Google Colab, and that will consist of a review of the topics that we discussed in the previous mentioned presentation. The students will then get to try out and experiment with Python fundamentals before starting a small project that will test their knowledge gained up to that point. When it comes to coding curriculum, I really believe the sky is the limit there, and if we're successful in getting our students to engage with it, then we could definitely move into more advanced projects with more open-ended solutions. So just wanted to say thank you for this opportunity to participate in WySTACK this year. And yeah, we had a really great time working on this project.